Hi everybody in Algebra 2 land. This is just a short video to review some of the concepts with working with exponents and radicals. You know this stuff, but we're going to go through it anyway real quick. So first of all, exponential rules. Um, I've got highlighted up here the rules that you've learned when you have a base carried to an exponent and then all of that is raised to another exponent. You can simplify it as the base raised to the product of the exponents. And of course, if you have base to an exponent times the same base to another exponent, you can write it as that one base raised to the sum of the two exponents. Important to remember in this one here, the bases have to be the same. If they weren't the same, I'd be hard pressed to figure out what to use as the base on the right hand side. But when they're the same, of course, it's the same. So the first example is an example of this one here. So let me switch colors on you. And the other thing I wanted to point out is on these kinds of questions, what we're going to do is simplify this expression on the left-hand side so that it's x raised to some power. And then comparing that with x to the a, we're solving for a, but we just want to get x to the a equal to x to some number here. And at that point, we could say, well, a is just whatever the exponent is over here. But I'll show you. Better to show than to tell. So if I go and simplify this thing on the left-hand side, I've got x to the 2/3, and that's raised to the second power. So we're going to multiply these exponents together, and we'll get x to the 4/3, that's 2 times 2/3, equals x to the a. So at this point, all I'm doing is looking at this and saying, well, if these two expressions are equal to each other, and they both have the same base of x, then the exponent here must be the same as the exponent here, which means in this case that a is equal to 4/3. All right, so that's all we're doing. All right, let's try another one here. I'm going to go and grab this piece on the left-hand side and simplify it. So I've got the product of these two base to powers, which is an example of um, this guy over here. So we're going to add these two exponents together. We're going to get x to the 3/2 plus 3, which is x to the 3/2 plus 6/2 equals x to the 9/2. So in that case, again, remember, because this is x equal to x raised to the a power, we can say that a equals 9/2. All right. Now we've got another fun one. You have here x to the 3/2 is in the denominator of this fraction though. And so what you should remember is that when your exponent is in the denominator like this, it's really the same as x to the negative 3/2 in the numerator. Well, again, let me show you in case you don't remember. So I'm going to write this without the fraction. It would be x to the 5/3 times x to the negative 3/2. And now I'm going to follow the same rule I followed in the previous one. We're going to add these exponents together. We have the same base multiplied together. So this is going to be x to the 5/3 minus 3/2, all up there in the exponent. Fraction stuff, huh? How about that? 10/6 minus 9/6 equals x to the 1/6. And again, that x to the 1/6 sixths equals x to the a. So a equals 1/6. Here we go. And here we are on the next page. We're going to look at some radicals. And this is going to depend on this rule, which you remember, if you've got a root, an nth root of something raised to a power, we can write that as this thing, this base over here, raised to that power over the root number. So this rational exponent translates to this in root or radical form. And we're going to use this idea to simplify some expressions that have a common base inside the root or radical. All right, so first one, root 5 times root 5 cubed. So what I'm going to do here is rewrite this with exponents instead. So 5, the root 5, just the square root of 5 is 5 to the 1/2 power. I'm going to multiply that by 5 to the 3/2, because again, when you've got a root with no number shown here, it's implied that it's a square root, which means it's going to be an exponent with a 2 in the denominator. This power, this exponent of 5, goes in the numerator of the exponent. Okay, so now we have the product of these two exponents, and that's going to be 5 raised to the sum of those, which is 5 to the 4/2, or 5 squared. Well, yeah, we all know that's 25, but whatever. Okay, easy peasy, right? Okay, let's try the next one. Tap, tap, try to get something out of my view here. Okay, so a similar kind of question. Here we've got, I'm going to write it with exponents. Base is 3 raised to the 1/6 power times 3 raised to the 1/2 power, because this is an implied square root without a number there. It's just a square root. I mean, a root without a number is just a square root. So that becomes 3 to the 1/6 plus 1/2, or 3 to the 1/6 plus 3/6, which is 3 to the 4/6, which is 3 to the 2/3. And I think I'm writing them in this form because I think generally in Delta Math, that's the form that you're comparing these two in the drills. So this one pulls out all the stops. 4 to the 5/3 times 4 to the 3/4. Ugh. 4 to the 5/3 plus 3/4. It's really, all of this stuff is an excuse to get you to practice working with fractions. Did you know that? Yeah. So this is 4 to the, oh dear, let's see, 20/12 plus 9/12, which is 4 to the 29/12 power. Now, if you're like me, you would say it is not at all obvious that this expression is going to be equal to this expression. But hey, it works out. All right, that's all for now.